to go over for AC induction motor how to get the rotor angle. This is me at the beach, so please concentrate. After we're done, I'm going to the beach. So here's the block diagram of how to calculate the rotor angle of the AC induction motor. So we have a block called estimator. So it takes the I alpha and I beta of the rotating frame of the current, and then we're taking the stationary frame of the current I alpha and I beta, and we're taking the stationary frame V alpha and V beta into this block. Here's equation number 1. To get the induced back EMF of the alpha, we take V alpha, which is the input of the estimator, minus the internal resistance of the I think this is a typo. I think this should be I alpha, but I'm not sure. Anyway, either I beta or I alpha, and then minus the inductance of the this is inductance of the AC induction motor, and then we're taking the derivative of the I alpha. Same thing with induced back EMF of the beta. You take VB minus internal resistance times IB minus the inductance of the derivative of the I beta. And then the second equation, we're converting from the alpha beta frame to the rotating frame of D and Q, of the D axis and Q axis. So this is the Park transform. So here's the equation. Remember, this is the angle of the estimation. So we're trying to estimate this, which we don't know yet. And then here is the diagram. So we're trying to estimate. So this is the alpha, this estimated alpha. Estimated theta. And then, so assume this is our estimated theta, and then this is the actual theta rotor angle. So the difference is going to be a delta theta, which is the air angle, the air between the estimated and actual. And then here's the equation. So the back EMF is this equation. This is a constant, so equals the change of the magnetic flux. Okay, magnetic flux equals the induced back EMF, and then we're breaking down into D axis and Q axis. So D is going to be this constant times the change of the magnetic flux. So when when the flux is not changing, then it's 0. And then this is EQ is going to be this constant times the rotor speed times the magnetic flux. So then we can calculate the rotor speed. It's going to be this constant divided by the magnetic flux times EQ. And then this is the equation that we have to use in order to calculate the rotor position. So depending on the ED is positive or negative, if the positive ED is positive or negative, then their sign can be. So they have this sign. So it's pretty much just constant divided by the magnetic flux, and then EQ minus whatever the sign gives you of the EQ times ED. And then after we get the rotor speed, then you can integrate the speed into the rotor position. Thank you.